So here's a brief video on vertex form, starting out with a quadratic in standard form, ax squared plus bx plus c. That's this. We want to get it to this form. Notice the a. This will match the leading coefficient in standard form. And then we want to get it to where h comma k would be our vertex. Again, h comma k is the vertex. So a couple of things about the quadratic that you're given here. F of x opens up because it's a positive leading coefficient, meaning the vertex would be a minimum. So two things we wanted to be aware of. We wanted to isolate the first two terms away from the constant. And the second thing was we want the leading coefficient to be 1. If it's not 1, you have to factor it out. Check out my other video, vertex form in 1 minute, for an example where the leading coefficient is greater than 1. So this is not a GCF problem, it's more of an algebraic manipulation to set up the perfect square trinomial. So we take our b, which is 6 divided by 2, quantity squared, we get 3 squared, which equals 9. So what we need to do in order to complete the squares, we have f of x equals x squared plus 6x plus 9, and the minus 2 out here. Now, you always have to keep an equation balanced, so whatever we add on the inside here, we also have to take away on the outside. This means 9 minus 9 is actually 0, and our equation remains balanced. So the next step then is to finish off vertex form. So this whole trinomial is now factorable. Remember, we always keep this number in mind, so it becomes x, and then whatever that number is, it's a positive 3 squared minus 11. And that means our vertex is negative 3 comma negative 11. Remember, the x is always opposite, and that comes from our transformations. And then if I needed to talk about that axis of symmetry, A of S, that would be the imaginary vertical line that goes through the vertex, which is x equals negative 3. If you have any questions, let me know.